Alright guys, Buildzoid here, and this is going to be a very random video. So as you can see, I have a Gigabyte GTX 680 Super Overclock card, because there was one on eBay and I just couldn't resist. I've always wanted one of these because it's one of the most ridiculous GTX 680s ever made, but unfortunately what the seller didn't mention about this one is that it's actually like some engineering sample card, so it came with a BIOS that was really garbage. Um, like that was like right off the bat, like the BIOS, like when I first got the card, it wouldn't run above like it was hovering around like 1060 core, which is really low for a GTX 680, or at least GTX 680s I care about. I don't remember what like the stock spec is, but like I have a 680 Lightning that runs like 1200. Then I have a couple 770s. They'll also run around 1200. So basically, I was like expecting this thing to run around 1200. And well, now it does, because I've actually flashed a retail BIOS onto the card from the Tech Power Up BIOS database, which is an absolutely great resource. But initially, like, the annoying thing is, like, since this is an engineer, like, there was also a subsystem ID mismatch, which I had to override, but well, that worked out fine. Like, I don't even know why that came up because it's still a 680. Like, it's an engineering sample 680, but it's still a 680, so I'm not sure why that was a problem. But yeah, this thing runs really hot. Um, which I'm very disappointed about. Like, we just started Firestrike and it's already at 70 degrees, but I had a run previously that topped out at 85, and I wasn't even running it for that long. Now, you might notice the fans are doing almost 7,500 RPM, and you might think they're going to be super loud. They're actually not that loud. Like, not for a 7,000 RPM fan, and that's mostly down to the fact that they're 40 millimeters, so, the actual sort of blade tip speed isn't really that high. Like, these are really little fans, so they can spin pretty fast and not make a ton of noise. Unfortunately, at low RPMs, so right now most of the noise I have from the card is like wind noise, which, is kind of to be expected. But at low RPMs, these fans actually produce a bunch of bearing noise, which is really annoying. So you can like hear the bearings rattling around, but the card's pretty old, so it's probably part of it. Anyway, so yeah, I'm pretty like the good news is now it actually runs at like good clocks and it seems to be stable, but it runs really really freaking hot. Like 85 degrees as far as I'm concerned is completely unacceptable. So I guess maybe the thermal paste on this thing, since it isn't old, like the card's not even remotely new. It's also a bit warped, which I'm kind of sad about. At the same time, I'm not really surprised. The heatsink on this thing is absolutely stupid heavy. And not very efficient, as we can see from the cooling right now. But maybe that's just a thermal paste thing, or at least that's what I'm hoping it is that it's just a thermal paste thing. So we're just gonna shut this down now, and I can't see. Shut down, and we're gonna replace the thermal paste, and hopefully that fixes it. So let me just shuffle around the mic. Oh man, this thing's really hot right now. Yeah, it's like, oh yeah, the card went up to 85 degrees. Let's just pull it out of the system right after running Firestrike. It's a great idea. Also, it's like all metal backplates and everything, so like if you touch something that's made of plastic and it's really hot, it burns you less than if it's metal, because metal's more effective at transferring all that heat energy into your hands. So that's why like metal objects that are kind of warm feel much hotter than like equally warm plastic objects. And by that I mean same temperature. Man, this thing is actually a pain to pull out of the board because it's so damn heavy. So yeah, because like it pushes the clip on the PCIe slot down with its own weight. Come on, there we go. So yeah, I'm a huge fan of the PCB because that's a lot of pro-adlizers. Yeah, I'm just gonna say pro-adlizers. I'm probably mispronouncing that. Very fancy type of SMD capacitor, also notorious for failing at high operating temperatures. So yeah, I'm not super confident that these made it, considering how hot this runs. I'm hoping that this was more like a card that somebody had sitting in their collection, rather than a card that they were actually running. But at the same time, it's like, I wonder how it got this like bend, right? Like this looks like it was sagging off of a PCIe slot for a while. So, eh. Yeah, not the best condition for a card like this. Also, there's the heatsink. So Gigabyte had the ingenious idea of like this is not quite as bad as like blower heatsinks where like the whole issue with a blower heatsink is that you're trying to shove air through it this way. And so you have a very small cross section and so you have to move the air very quickly to get any amount of decent cooling done. Now Gigabyte with this card had the idea, what if we just like pull the air through this massive fin stack from the side? So the cross section's actually relatively okay, but the end result at least so far, seems to be kind of awful because it hit 85 degrees. Now, admittedly, this thing, runs 1200 core at stock, but that's still with a stock power limit of the tech power up lists the BIOS that I put on this card as having a 225 watt power limit. So it's like it really isn't actually putting that much power into the heatsink. Like for 220 watts, I would expect a good GTX 680 heatsink to top out around like sub slight like 65 to 75 degrees depending on the card. So this thing's running pretty damn hot. We're unfortunately not going to be pulling the backplate because that's not necessary for just swapping out the thermal paste. It's only 6 screws to pull off the main heatsink, which is kind of nice. Like, easy to take apart at least. And this thing's also a bit dusty, which... Yeah, I think somebody dailied this. I'm surprised that they dailied it considering that it's like an engineering sample card and it doesn't even run that fast. Like, seriously, it was 1060 on the BIOS that it came with, which is slow as far as I'm concerned. So, yeah, let's see. Oh, yeah, that just pops off. Oh, man, the fan cables are all butchered. Oh, somebody replaced one of the fans. Okay. My level of disappointment keeps increasing. Ah, eBay GPUs. Anyway, so that thermal paste doesn't look in particularly great condition. Massive vapor chamber and then heat pipes. Very, very heavy heatsink. But, yeah, I don't think this is the most efficient way of doing a heatsink with this much mass. Like, I'm pretty sure. Like, actually, one thing I was considering when I was first looking at the card was if I could pull off the top shroud, which, actually, we're just going to keep it plugged in. So, the idea I had was pull off this, cover and just put, like, 2 120mm fans on top of that, and that would probably actually do a better job than what Gigabyte did here. But the fin stack, the fins are folded over, so even if you pull this, it's still, you can't force air into the fin stack from the top. So that kind of totally just, well, like technically you could like hand bend all the fins open, but it's like I'm not putting the time and effort into that. That's going to take forever. Anyway, so here's the card. Yeah, so in order to get the prod lasers on there, they really have the VRM a mile away from the actual core, because prod lasers take up a lot of PCB space. We've got a 8-phase V-core VRM using, I believe it's on 60 amp power stages from IR. And, well, they are IR part. Let's wipe them off. Do I seriously not have... Oh, let's just grab a paper towel then. I'm covered in silicone oil, so that's not going to work very well, but... I want to be able to read them. Let's just pull the whole thing. And that is... So that's an IR 3550, which is actually a 60 amp power stage if I remember correctly. So, yeah, so we've got a 8-phase using 60 amp power stages, which is actually solid for a GTX 680. Also, what I find really interesting about this card is its main input shunts are actually 2 milliohms, whereas most NVIDIA cards are 5 milliohm on the main input shunts. But then we have these two 5 milliohm shunts down here, which is kind of like, what's that for? We have an input fuse on the... There's a little fuse... I'll do a proper PCB breakdown of this later. Let's replace the thermal paste, that's the main thing. I really hope it's just a thermal paste thing. And that the heatsink isn't actually as bad as it seems to be. Because that would be pretty disappointing if you had this much vapor chamber and this much fin stack and then just card runs at bloody 85 while at stock power limits. There's a reason why. At the same time, that would also be like a good proof of like why you don't build heat sinks like this. It's just like, well, it doesn't actually run that cool, does it? But also, like, this is actually a really silly heatsink design because I think the idea behind doing this was like, oh, if you run multiple GPUs, they won't like have because it just pulls air through the fin stack. So it's like you're not going to have the card pulling hot air off of the back of the card in front of it into the fin stack. But it's like, but this is 3 slots. Like you can't run like you can't run more than 3 of these in one on a normal. Well, like there are some motherboards where you could run 3 of these at most. Realistically, you're going to run 2 of them. It's like, yeah, so I'm not really a fan of the heatsink design here. Like, it just doesn't make a ton of sense in any way, unless the temperatures, like, significantly improve after I swap the thermal paste. But honestly, the stock application doesn't seem like... I don't know. It doesn't look that bad immediately, but the thing is, judging thermal paste based on, like, how it looks after you pulled off the heatsink generally... Like, I don't think that works that well a lot of the time, where it's like, oh, this doesn't look that bad, and then you replace the thermal paste and the temperature drops 15 degrees, and it's like, oh, actually, it was bad. At the same time, the heatsink might just be garbage. Because actually, like, the fun fact, fans are generally not good at pulling air through things. Like, you're much better off trying to push air into a fin stack than trying to pull it through. So, honestly, this heatsink probably just isn't very good. So we're going to throw some KPX on there, which is basically the best thermal paste that I have on hand right now. And yeah, if this doesn't improve the thermals, then the heatsink just kind of sucks, which wouldn't surprise me, and it's a good thing. Like, and I wouldn't really care because I primarily bought the card for the PCB, not the heatsink. But you know, it's still kind of disappointing if the heatsink does suck, because it's like, why? Like, look at how much metal they put into this to get such unimpressive temperatures, right? Like, just disappointing from that sort of perspective. Oh, this is a lot easier to spread thermal paste on a warm GPU core, and I'll just dab the rest of it onto the fin stack a bit. Oh, really? I don't need to be accurate with that. Like, there's plenty of thermal paste on the core itself. So, yeah, I wonder if actually, if the card was hanging out in a case, right, and getting pulled, then there's a chance that the heatsink was like getting, like, it's so heavy that it was pulling away from the core. So the thermal paste was just getting like not enough mounting pressure, and that would actually make it worse in terms of longevity. Man, okay, this cable management is not, how the... Where do you stuff all of the cables? Oh well. Like, the cables are really getting in the way. Okay. Oh. Well, that wasn't really the sound I wanted to hear, but should work. We're gonna do the core first, so that the thermal paste... These screws are too short, in my opinion. Yeah, like, there's not enough, like, length to them, so that you can really, like, start them off lightly and then tighten them down a bit. They just max out right off the bat, which is not ideal. Because basically it would squish down one corner of the die first, which is not so much, like, the concern there is that it, like, makes the thermal paste application uneven, because the screws are so short. Oh, well, I'm perfectly happy to run this card with a different heatsink. I have a bunch of spare NVIDIA heatsinks and AMD heatsinks at this point, so if this heatsink is literally just bad, then I'm just getting rid of it. It's not a problem. Go. Oh man, that first startup with this card, it always ramps all the way up. And I'll try give you an idea of the bearing noise. So, I don't know if that picked up on the mic properly, but basically the card has a like slight buzzing sound to it at low RPMs, and at high RPMs it's just wind noise. Okay, so the capture card is cooperating today. Yay! And let's see if the temperature's improved. Now, well, so basically what I'm looking... I should have taken like a screenshot of the temperature ramp, but... on like the previous run. Because the thing is, we're like, unless you let the card burn in for like a while, you're not gonna... Like, it's hard to judge the temperature, like the heatsink performance quickly. Right, so anyway, we're just going to run GT1 on loop, because GT1 actually pulls like the most core power out of all of the graphics test. Graphics test 2 is more like memory sensitive. But GT1 has some really nasty power spikes in it, so that's like the thermal test. And the thing is, like, this heatsink, like, I actually heard, like, had some people tell me that the idea behind this heatsink is that it's so heavy that it actually takes a while to heat up, and it's like, nah, it doesn't. When I first ran it, the temperature just immediately shot up. Wait, I said windowed. No, not full screen, I wanted it windowed. So that we can see GPU Z. Yeah, and like on the engineering sample BIOS, the heatsink actually looked like it was doing a decent job, but that engineering sample BIOS was like hitting the power limit constantly. Also, the power draw, like, did anybody see that? Like, it just hit 200% power draw. What the hell? So hopefully it does, like, the power management seems to be bugged out. That's lovely. Oh, well, I have a fix for that. Okay, now we're running 1215 right now, VREL, VOP, so all looking good. Okay, so that just looks like some kind of glitch in the drivers or monitoring software. Yeah, now we're running 80 and 52 degrees. Okay, so it's not doing such a bad job this time. Because previously, when I fired it up, it basically shot up to like 60. At the same time, like, the heatsink was hot. So I'm not sure that I can... Well, let's just watch it. Let's just watch it for a little bit. Man, at 4,000 RPM, the bearing noise is so annoying. Like, the fans are just rattling. I wonder how hard it would be to get replacements for all of them. And we're at 57, 58, and steadily climbing. Lovely. So, like, for a good card, I expected to flatline at like 70. But previously, this really hasn't done that. Also, the VDDC power reading seems to be just completely wrong. I think it's off by a factor of like 3, which is kind of weird. Like, it shouldn't be off by a factor of 3, but like a factor of 2 would make sense because there's like scaling variables for that kind of power draw, but because the overall card power limit is 225. So the core should be pulling somewhere around 150, if not like 180. And so it doesn't make sense that the VDDC power draw reading in GPU-Z is just 60 watts. Anyway, so we're at 65 degrees already, so that's unimpressive to say the least. Admittedly, the card's doing 1230 core, which I think is the highest like stock boost I've seen on any 680 I have so far. Most of my other ones do like 1214, I think. For my other, well, I say 680s. I consider the GTX 770 a 680 as well. So I like when I say 680s, I include my 770s in that. Which you shouldn't really be doing, but I actually want to mess around with like backflashing the 770s to 680s so that I can do like a quad SLI setup with a bunch of 680s. And normally the NVIDIA driver won't let you do that kind of thing, and we're at 68 degrees, and the fans are at 7,000 RPM. Yeah, this heatsink just doesn't do a very good job as far as I'm concerned. So it wasn't the thermal paste, it's just bad. And there's 69, which is not very nice. Because like it's also at 7,200 RPM, so now we're in the outside of bearing noise and more wind noise range. And my disappointment in the cooling solution keeps rising. Actually, what polling rate do I have GPU-Z set to? Yeah, it's 1 second polling rate, so I wish they had a time, like some kind of time indication, so that we would have like temperature increase per second metrics. Yeah, like the thing is, like previously I ran it and it hit 70 and I was like, oh, I hope it settles out at this point, but then I just left it running and it ended up at 85 degrees without me paying attention to it. So heatsink kind of garbage. Like I have other cards that hit 7. Well, admittedly that's on short runs, but yeah, well, I'll have to run a proper comparison, but the thing is, like, I was not impressed so far. This just generally seems kind of hot for a 680. And it's not even running that much voltage. Like, the GPU-Z is reporting 1.137, which is actually, it's pretty low for 1200 core. So maybe I got lucky with the silicon on this. Because I think a lot of my other cards actually go to like 1.2 for their 1200 core. Or was it 1240? I have to check. And we're at 73. I think it's improved a little bit, but it's still really loud. Also, here's a scary thought. That is apparently 51% fan speed. So I'm kind of wondering, what is 100% fan speed like? Like, I'm pretty sure it hit 100% during a few startup attempts, but I'm really starting to wonder. Oh, it only goes to 75%. Oh, well, here goes. That's not that bad. Like, I was expecting it to screech, but it's actually kind of deep. Like, I don't know how much that picked up on the mic, but, like, that's a lot deeper in pitch than I was expecting. Like, I was expecting the AMD, like, reference card experience, but... Which is like, AMD reference card is, like, really shrill, if that makes sense. Like, it's high-pitched, it's rattly, like, you hear, like, the resonance of the plastic shroud over the fin stack, and you just get this horrible, screeching noise out of the card. But this wasn't that bad. But the temperature still sucks. It was still at 70. Like, the temperature didn't really change. So... I'm gonna put it back to auto. Yeah, I'm not impressed with the heatsink. Hey, it's a really interesting card, but what I really want to do is do some oscilloscope measurements, because with all those, like, the idea behind the Pro Analyzers is that they're these super huge SMD capacitors, and so they have extremely low ESR and extremely low ESL. Like, I think some of the Pro Analyzers I've seen, their rated ESR is like 2 milliohms. And their ESL is supposed to be super low as well. Like, the original idea behind these was that you would put them right behind a GPU core instead of your high-frequency multi-layer ceramic capacitors. And this card has 4 of the damn things just on the V-core, right? So I'm kind of wondering, like, does this thing have better voltage regulation than, like, my Lightning or my Classified? Because the Classified and the Lightning, they both use more conventional capacitor configurations for their power filtering, but they both do a really good job anyway. And so I'm kind of wondering, well, does Gigabyte's crazy, 4 Pro Adlizer output filter do a better job than what like MSI and EVGA have? At the same time, I'm kind of concerned that since the Pro Adlizers are kind of known to fail from high operating temperatures, and this card like doesn't really run very cool, I'm kind of like, are these maybe dead at this point? Because they might be gone. So yeah, I wonder how I'm gonna test that. Because only like it's also a really rare card, so it's like I don't want to like butcher it or anything for the sake of like test data. So I'm kind of wondering like if I had a second one, right, then one of the ways you could test if the Pro Adlizers are dead is like you could pull off the Pro Adlizers and see if anything changes about the voltage regulation. If it doesn't, then it's like they weren't working anymore. Because there's not really any other way to test them as far as I'm aware. Because they're in parallel with a whole bunch of other capacitors. So if the Pro Adlizers are gone, like you're just going to see the voltage regulation performance of the rest of the circuitry. So yeah, I'm kind of wondering about that. Also, they're a massive pain to remove because a Pro Adlizer basically has like the center of the Pro Adlizer is just one massive ground pad, and then you have 2 like power strips on the outer edges. So they're like, and they're huge. Like they're basically like trying to pull a GPU core. Except they're made of plastic, so they also just disintegrate at high temperatures. So, yeah, the last time I tried pulling Pro Adlizers off of a GPU was very unpleasant. Let's just put it that way. It was a dead GPU, but yeah, like, not a fun experience whatsoever. So, anyway, I think I'm just going to end this video here. Because, I don't know what I was doing. I thought maybe... Like, I really underestimated how long I need to let this thing run to get up to temperature. So I'm just going to let it run like this. And if it hits 85 degrees again, then, I'm disappointed in the heatsink. And I might leave a comment in the... I'll put it in the description if the card, like, stopped hitting 85 degrees. It's still loud, though. So, like, I'm still not impressed. Like, even if it stays at 75 degrees for the next 3 hours, it's just, like, I'm unimpressed. Yeah, I wasn't really sure what I want to do with this card in terms of videos, but I recently got it. It's cool. Like, it's a cool card. And, well, the PCB's cool. The heatsink's not. Literally not. Because it's bloody 75 degrees at stock settings. But, yeah. I don't know. This is just another one of those random videos, so I'm just going to end it here. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with AHOC, I have a Patreon where you can support me directly. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. And there's a link to that down in the description below as well. That and the Patreon both, help out immensely with running the channel, so it would be much appreciated if you would check them out. And that's it for the video, so thank you for watching, and goodbye.